discoveries that have been made, one of the most important is the detection of water ice throughout large regions of the northern pole. This is important because most scientists believe that if life does exist on Mars, it will be in areas with high water concentrations. To help further our understanding of water and potential habitability on Mars, a new mission is being developed by NASA and the University of Arizona called the Phoenix Mars Lander. Phoenix will land in the northern region of Mars where evidence of ice-rich soil has been detected. This mission will use proven technologies to help unlock the mystery of Martian water and may help us determine the biological potential of the Arctic soils. I spoke with Peter Smith, principal investigator for the mission, to help us find out more.
Phoenix mission is an attempt to land on Mars and understand a polar environment for the first time. We're hoping to understand the history of water, and we are looking for evidence that life could potentially be living in this kind of an environment where ice and soil are closely together over long periods of time.
Peter, what are the mission's science goals?
The discovery of ice in the polar regions has given us an opportunity to perhaps find the large reservoir of water that's been searched for many years on Mars. So it's a really exciting opportunity for us to go as quickly as we can back to Mars and dig down to this ice that's been seen from the gamma-ray spectrometer that's in orbit around Mars, to understand the chemical and physical properties of the ice and the soil that's associated with it, to understand the history of that ice. And in addition, we want to know the active processes that are allowing the ice to sublimate into the atmosphere, creating water vapor in the atmosphere. And we want to understand how the atmosphere can also freeze out into the soil. Finally, because this ice has the potential of melting as Mars goes through climate changes, it's a possibility that this is a habitat for Martian organisms. And we are hoping to be able to understand the properties of this habitat, whether the water has been liquid, whether there's energy sources that would allow microorganisms to survive, and whether there's in fact organic molecules associated with this layer of a complex enough nature that there might have been life in the past or even current life.
What are some of the instruments Phoenix will be using to help accomplish the mission?
First, we have cameras. And then, besides looking at the environment, we're going to interact with it with a robotic arm. And we can dig down as much as 3 feet. And probably we can't get that deep because the ice is very hard. And so we're probably just going to get down to a hard ice layer and then scrape off samples. And as we collect samples of both soil and icy soil and ice, we will deliver them to 2 instruments on the deck of our spacecraft. And there we'll do a chemical analysis of the soil samples to try and accomplish our science goals.
Didn't the Viking landers in the 1970s dig as well? Why would we need to do that again?
Well, the Viking mission in 1976 had an arm also, but it basically had a little sample collector, and it was able to collect samples from the surface. They actually moved rocks and got samples from under rocks, but they did not have the capability to dig down 2 or 3 feet like our mission will do, and they did not have an ice layer underneath that would change the soil as it melts. So hopefully we start with what they learned on the very top surface. We expect to see something very much like what Vikings saw, and then we move into an unknown realm as we get near the ice layer.
Like its namesake, the Phoenix lander rises from remnants of its predecessors. Phoenix will use many components of a spacecraft originally built for the canceled 2001 Mars lander mission, and will also include improved versions of other instruments flown on the lost Mars polar lander. Because many of these instruments have already been validated, the cost and turnaround time for Phoenix is relatively short. Once on the ground, the instruments used on Phoenix will analyze the soil and atmosphere, then send that information back to Earth via a relay through NASA's Mars Reconnaissance Orbiter, as well as the Mars Odyssey and Global Surveyor orbiters. NASA planners believe that this low-cost option will reap huge dividends in the form of scientific knowledge.
It is a lot of money. I think everybody knows that. However, we do not send the money out into space. The actual value of the physical things that go out there is very small. The money is spent within our aerospace industry, at our NASA centers, and at our universities. And it goes to develop an expertise in our country for understanding how to explore planets, how to design the most advanced communication and propulsion systems, how to engage the public in interesting exploration missions. The money goes for very wonderful, peaceful purposes. And I think this is the age of exploration, and it behooves us to go out and do it. We expect it's going to be one mission after another, each building on the discoveries of the last. And that's how we're going to understand our neighbor.
One tool that will be invaluable on any mission into space is a spacesuit. Whether floating around the International